That's as much as I can get in.
Our next experiment is going to be a chemical change. And what we're going to do is we are going to use the ingredients of baking soda. How'd you know that? Have you done this before?
I've done this many times.
Well, then in that case, why don't you tell me what we're going to be doing? But here we're going to do it 3 different times, which I did not get to do with the group yesterday.
What group did you have yesterday?
5th grade.
Oh.
I would like for you to tell me 3 different sizes of teaspoons we're using.
I did 1/4, 1/8, 1/2.
Can you arrange them so that they're in order from the smallest to the largest?
Evens, about 2/4.
There you go. 1/8, 1/4, and 1/2 of a teaspoon. Your challenge is using this funnel to fill 3 beakers. You've got your little test tubes right there, about halfway full. Okay?
Miss Palmer.
Yes.
You know how I knew that?
How?
Look, tiny, medium, and...
Well, you use all sorts of clues to figure these things out, but I also saw you using your knowledge of fractions because I saw you doing that. All right, so would you please...
These all lead up to an 8. Well, it depends on which one's higher.
Okay. All right, pick your first one, and I want you to put... Fill it about halfway full of vinegar with your funnel.
You want me to dump the water on?
Is there a little bit of water in there? There shouldn't be much in there. There you go. All right.
Okay.
Okay.
I'm not taking out a second.
And it doesn't have to be exact.
You said 1/2, right?
About 1/2.
Okay, that'll be fine.
Okay. What I would like to suggest in the interest of time is that you go ahead and uncap the other 2 so that you can go ahead and pour all 3 of them with their vinegar before we start the next step. Okay. All right, put your funnel in. Pour some vinegar neatly, please.
Oh, I need to take this chair back.
Okay. Up. Oh. Oh, slow down. Stop. I think we got more than half.
Oh, it was about 1/2. I think we're going to have to dump back.
All right, here. I have a few papers
Sorry,
that I in there.
It didn't have like the actual thing. I can't see, so I don't know how much I'm
It's
pouring.
okay. It's okay. I did this a little differently than I did yesterday. So I'm going to try to pour some of this. You look at the side and tell me when it looks like I've got it about half full in there. Trying to do it without making a huge mess. Like that. I'm making a huge mess. Oh, you're going to smell like vinegar now. What do you think? About there?
A little bit more. That's it.
All right. Let you do the same thing here.
Okay, so we just put this one down.
No, you're going to pour it from there into there because you should be able to take some of that.
But not all.
But not all of it. About half of it or so. That's probably nice enough.
We're going to have to dump a little more.
All right. There you go. Let's start back with that one. And, all right, much slower this time. Maybe a smidge more. Oh, that's good. That's going to be good right there. Beautiful. Now,
Just put the cap back on.
to make our, thank you. And I got the cap right here. Wrong cap. Well, I'm sorry. All right, to make our chemical reaction, we're going to start with the smallest of the three measures. And which one of those did you say was the smallest?
This one.
All right. Your challenge is to, with 1/8 of a teaspoon of baking soda right in here.
I know what we're doing.
Aha, what are we going to do?
We're gonna put the balloon over this, and it's gonna fall in, and it's gonna make the balloon.
Okay. What I want you to do is put it on there, but don't tip the balloon up yet. I'm going to get you another balloon so we can continue with the next two sizes.
It's fine, we're gonna need you to hold it like the back of it. It's harder than it looks.
It is, and I had to get smaller test tubes. Don't dump it in yet. Okay? Tell you what, let's do it this way. It might be easier if I bring it to you. There.
Put it down. Okay, there we go.
I think that's going to work. Now, we're going to do the next larger size in the next balloon.
It's a bigger balloon. Oh, do we have to put the exact same amount? We're gonna put.
No, well, we already did the 1/8, so put that away. What's the next larger size? Okay.
This one should be easier since it's a bigger balloon.
It should be. I think it's bigger because I used it yesterday.
Oh.
I'll hold this and you do this. Ah, yes. Okay, and the last one. Okay, let's put that down until we get the balloon loaded.
Okay.
Okay. Okay, we now have your 3 different measures with more baking soda in each one. We're going to make a chemical reaction, but how are you going to be able to tell this is a chemical reaction? The chemical reaction we're going for today is going to create gas. What do you think is going to happen when we create gas in this balloon?
What will happen is that when you don't, so this is vinegar and baking soda. So when the baking soda falls into the vinegar is gonna, it has nowhere, the gas that it makes has nowhere to go, so it just goes up.
Okay.
That's where this is the balloon.
All right. So would you please activate the first one? Shake it all out there. You'll notice I'm holding the balloon on so that it won't go flying off the test tube, I hope. Okay, and how much did we put in this balloon?
This was, that was the 1/8.
The 1/8. All right, it looks like it's about stopped.
This is 1/8. Oh yeah, it was.
It was a 1/8 because the 1/8 is what?
Small.
Smaller. All right.
And this is 1/4, and this is the 1/2.
All right. Do you think you can hold the balloon on there by yourself without me this time? Let's see what the 1/4 one does.
This one's gonna take longer to blow up because it was already been used. It looks like a cucumber.
It does. I remember using this one yesterday. I have to show you the video. All right. Has it finished expanding?
It
Looks like it's losing air somewhere.
There we go.
Okay. But looking at these two, can you see a difference in the amount of gas that was produced?
Yeah.
What can you tell me? How can you compare?
The more baking soda, the higher it goes.
All right. Now we have 1/8 of a teaspoon. How much here?
1/4.
Fourth. And how much did you put in there?
1/2.
All right, are you brave enough to try 1/2 and see how it goes?
I'm gonna put this on so it doesn't fly off.
Okay.
I wash my hands. You have to sink.
I don't have a sink, but there's a boys' room right across the hall. You want to wait till after we do the third one? Okay. All right, let's do the one with 1/2. Okay, this one has a hole in it. It's not holding up as well as I thought it would. All right, ready? And go.
Whoa.
Oh my goodness, that's an odd shape.
That looks like a balloon.
What can you see?
Wait, no, it
say
actually
about
looks like
the
a car mirror. Look, like a car mirror.
Oh, the shape of it.
Yeah.
Okay, how does the size of that balloon compare with the other two?
This one, there's more baking soda, so this one.
Okay, so why do you think it's bigger? I mean, there was more baking soda, but what does that mean?
More baking soda and the vinegar. The vinegar makes gas, and the more baking soda, the vinegar makes more gas, causing the balloon to go.
Very good. Can you see by looking at that if there was a chemical change? By looking at the water, the color of the vinegar?
It looks like soda. I want to drink it, but I know it's gonna taste bad.
But you can't really just tell by looking at things that they've had a chemical change. This is one of the ways you can tell, and that is because gas is produced. We're going to do another way in a moment. In order to do this other way, we're going to need you to dump out all 3 of these into the boys' bathroom sink, and while you're in there, you can wash your hands. Okay? Can you handle all 3 of these?
It's like hot. It's because my hand grew.
Can you take that one too? All right, and I will prepare the stage for the next experiment.
That looks funny. They look like bubble heads. No, this is like a Snoopy bubble head. This is like a little Charlie Brown.
You want to get in front of the camera and show it? I can always take a picture from the video.
Woo, 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 woo.
Okay. All right.
I also took these off.
Well, thank you. You put those back in the stand here.
You want me to put the lids back on?
Yes, please.
The first time I took the balloon off, it shot off and a little bit of vinegar got on my face.
Oh, goodness. Are you okay?
Yeah, it was just like a little squirt.
Okay.
I think it was from the outside. So you got bleach and vinegar. Where'd you get the code cups from?
I went to a workshop to teach me how to do coding, And that was a freebie I got. Now, would you please do me one more favor and go fill that code cup with, fill it up as much as you can.
You want to go? Can I go there? Like over there?
Yes, you can use that sink. That'd be fine.
That door takes forever though. I didn't think of that.
Perfect. Thank you.
It looks weird.
Okay. We are ready to start the next experiment. We're going to do another chemical reaction, or chemical change, I should say. Now, we know that one way you can tell if there's a chemical change is by looking for gas to be produced. But another one of the ways you can tell is to look for a change in color. So, what I want you to do is I would like for you to fill each of those bottles maybe halfway full, however far you can get this to go. I will give you a funnel.
Oh, by the way, Miss Palmer, when you said fill it up as much as you can.
You really did take me at my word. Yes, you did. All right, let's put it to maybe the bottom of the word that I've written on there would be good enough. And we'll put water in each of these 3 bottles. Oh, probably right about there is good. Gets easier as the bottle gets emptier. There you go. And one more. Okay.
You want me to make it even with them?
It's not necessary, but if you want to add more to one, you sure can. Not too much now, because we want to make sure we can get the reaction to occur. All right. Now, in order to help us see about a color change, we need to add some color to the water. So I have given you 4 dyes. I would like for you to color each one of those.
Different color?
You can different if you want, or you can do them the same if you'd like. It's your call. About 12 minutes.
Red, blue. And green.
You will notice I've already labeled your bottles: vinegar, hydrogen peroxide, and bleach. And I have laid out 3 cups so that you can get into it with your eyedropper. What I would like for you to do is to add just a bunch of drops to each one. So in the hydrogen peroxide one, okay, you will pull from this container. Okay, so hydrogen peroxide is going in the one in the middle.
So I need to make the whole thing fill up with it.
You know, you just might. But as a scientist, you get to experiment and figure that out. Now, if we were doing a truly regulated science experiment, we would be counting how many drops you were squirting, and that would make us take quite a bit longer. Seeing any change?
It's turning purple. I put blue in there, right?
I thought you did.
Yeah. Yeah, that's blue.
Okay.
It's purple.
Okay. Now, the next step is to, because I don't have any lids for these, we'll give you a folded up paper towel and let you shake it around, stir it around so that it gets mixed up very well.
I just do this and rub it all out.
Sure. I think that might be worth a good idea.
There we go. Oh, that's much easier.
There you go. Now use this and shake it around. Not necessarily upside down, just, yeah. And as you shake it and mix it, is there any noticeable change in color?
Yeah, it's purple.
Yeah, but it's not a big noticeable change, is it? Okay, let's do the same thing with the vinegar one. That would be this.
Good vinegar?
Yep. Shake it up. Okay, it still looks red. Any noticeable change?
No.
No, not really. Let's see what happens when we do the bleach, which is your third container. Okay, compared to the color it was when you started, do you see a noticeable change in color?
Yeah, it's blue.
Very light blue, isn't it? It was the same shade as this a minute ago.
Well, that's because bleach, it makes colors different when it's put in.
And that's because bleach causes a chemical change. Okay? Now, we said with a physical change, you could probably undo it. You can unfold paper. You can put things back together.
You can't. This is a chemical change. You can't do anything because when you put something in water that's a liquid, you can't take it out. Well, technically you can, but it's hard.
It's hard. It's hard. And with chemical change, you really can't reverse it by taking the stuff out. So, this actually worked better than yesterday's. So, you think you have a grasp now on the difference between a physical change and a chemical change. Okay? Just for fun, the last thing I have to do with you is called magic sand. Would you like to go dump those three out for me, please? While I
And
get
look, the
this
bleach
set
is
up?
now green.
Yes, it's getting lighter and lighter, isn't it?
Mm-hmm.
Because of the chemical change, the chemical reaction between the bleach.
It's green tea.
Don't you do that?
Oh, it stinks.
Let's go dump these out. I'll give you the vinegar because even if you drink it, it doesn't do anything but make you sick. I'm not going to have you drinking hydrogen peroxide or bleach.
Well, hydrogen peroxide, that's what you use a lot. Well, my daddy made me make it like alcohol.
I've also put it on when you get a cut and you get a scab and it's kind of pussy. If you put hydrogen peroxide on it, it bubbles. It doesn't hurt, it just bubbles. Well, hold it up, look, see if I'm putting those two together. Let's turn on some water to wash it on that. Thank you. All right, now we're going to come back and do the last fun little experiment. We'll put these over here. And we still have some water. That is cool. Because you have your container of water, and I have here some sand. This sand is a special kind of sand that you buy for like those little Zen gardens that you rake and stuff.
Oh, is this a sand that never gets wet?
No, that's the mixed sand.
Oh,
This is regular sand. What do you think will happen if you put some of that sand in there?
It's gonna become what?
Give it a try. Now don't put all of it in there, please. Just enough so we can see what is it going to do. What did that sand do?
It sunk.
Think straight to the bottom. Why do you think the sand went to the bottom instead of floating?
Because sand has weight to it.
Yes, it has more weight than water, doesn't it? It has more density than water. So even if you shake it up,
Well, let's do that.
okay?
Oh, that's cool. Look at it. Oh crap! It's leaking.
No. Okay, so that's what happens if you put in regular sand. Now, I do believe you were just mentioning this, which is magic sand.
Which never gets wet.
All right.
This is really weird.
See what you can do with that. What do you think? I think you've seen this before, so what do you think is going to happen when you pour magic sand in it?
It's gonna also sink to the bottom, but it never gets wet.
How are you going to know if it's not getting wet?
I don't know. I just saw a video of it.
Oh, then this time you get to do it for yourself.
Yeah, and it turns into that. Some of it floats, but most of it just sinks to the bottom. But the weird thing about this is that when you take it back out, it's sand again.
You are right, and that is why I have brought a coffee filter to put on this cup so that you can pour. Ooh, we got more water than is going to fit in this, so let's do it in the container over here. I'll bring it to you. This is the result of yesterday's experiment.
So you just want me to like...
And after it dried overnight, you can see that it has turned back into magic sand that is dry. So we're going to let you get yours drained too.
Can I keep this?
I wish you could, but it is all the magic sand that I have. So, okay?
Where'd you get this from?
It's been so long ago, I'm not sure, but I think you could get it at like one of those Discovery stores at the mall, Discovery Science. All right, let's see if we can reclaim some of that sand from here by pouring it through this coffee filter. Oops, wait a minute. Coffee filter got out of control on me. There we go. As the water drains out ever so slowly,
it becomes sand again.
It becomes sand again, right?
I thought we were gonna like fill the entire thing.
Well,
can we do that and just dump like some of the sand in? Because I want to play around with it.
yeah, you want to play around with it. Okay, because I can always get the sand back out. Let me take out the paper towel. I will dry that
Yeah, I'll go refill
elsewhere. Please note, this is our first day working together, one-on-one. He used to be in the science group, but doesn't qualify anymore. But he needs this.
Just dump it in here.
That's going to be up to you. You're experimenting now. There you go. Now, before, it didn't go all the way to the bottom. What do you think is going to happen if you keep pouring so much sand that it reaches the top? Right now, it's moving around, isn't it, because of the wave of the water?
If I had this, I'd be playing around with it so much. Okay. It has to be still for it to actually sink, right?
Okay, if you can get it to not be moving. How do you stop water from moving, though? You can't. I'm going to encourage you to hold this upright and dump all of it in one place. Try not to move it. There you go. And watch what happens when it reaches the top.
It's sand.
Because it is not going down and getting wet until it gets
so heavy it starts to bend. And
right.
What's cool about this is that it bends the water.
There is
and you're actually able to make like little bridges with this. So like if you go over here and start doing this, you start doing that.
So you think you can, you might get it, yes. Cool.
Magic sand is the best.
And that's why we call it magic sand.
Because it's weird.
Okay, we have about 4 minutes left, Riley, so I'm going to stop the recording so we can discuss our plans for our next meeting.